Hello, this is going to be a troubleshooting video for my 3D printed tourbillon. Some people have been experiencing issues with getting the model to work, and I'm going to try to cover anything I can think that has been causing issues. There are a lot of inconsistencies that a lot of variables that people are going to be changing depending on their filaments or their print processes, so I'm trying to cover all of them, or try to provide solutions for all of them. So if you follow the tutorial, you should roughly remember the standard building. You know, your washer here, your washers actually on all of these. There's washers. Losing washers. Okay. Sorry. Washer right here. Place a washer right here. Have that. Okay, so first thing is we're going to test, or we're going to make sure we have a very loose fit on our escapement wheel. Friction will kill this mechanism faster than anything else, so we got to make sure that we have a very smooth escapement wheel. Same thing with our barrel. We have a little barrel spacer here. We're going to make sure that this can rotate very freely. And together should be pretty low friction. Next, we want to test our pallet. I'm going to make sure, now this pallet has to be very, very low friction. It needs to be essentially able to tilt back and forth just by the force of gravity. Because, well, basically, because of how the escapement works, if any friction is in these two components, it will just stop working. Next, we want to make sure that our little axle here is very free moving. As you can see, it is, for me at least. So, because all three of those parts are working for me, I'll continue through with the standard assembly. We'll add on our escapement. Actually, add our barrel spacer on, and then add. Just gonna wash a little washer. Get this. I'm going to do this slightly different than I did in the tutorial. I'm going to install the squisher without the spring attached to it. So this is another thing. When you're attaching the squisher, it's going to be a tight fit, but you don't want to brute force it. It's going to be tight, and I like to press first above this pillar, this little pin right here, vertically, and give it a good amount of force, and then apply force at the back. This case, I'm not hearing a snap, but you can see it's fully seated in there. It looks like this pin isn't fully seated, so I'm going to give it a little bit of force, but I'm not going to brute force it. And it's not, let's see, it doesn't have to be 100% seated. As you can see, in this case, it's not, I don't know if it's going to focus, it's not 100% seated. That should be completely fine. As long as it's not coming off, and see, it's not going anywhere, that's all we need. You don't need to brute force it. And hopefully that should stop this pin from breaking. Don't worry too much about it being 100% seated. Let's see. So then, let's get this whole thing. Now, another thing to note is, we're actually going to assemble this in a way that we can test it without this little hairspring here. So I'm just gonna snap that guy into place. You know, it should look like a standard assembly. But now I'm gonna show you is how the tourbillon actually works. So what I'm going to do is I'm going to apply a little bit of force. You should not, this does not need a lot of force at all, like just the slightest amount of force, and then start rotating the wheel. If you see, I'm just going to lightly bring it past. It will be a little bit of resistance, and it will kind of stick a little bit, and then sticking right here, get just past that breaking point, and the force being applied in the escapement wheel will launch the flywheel. That's how the whole mechanism works. This is a great way to test and see if your escapement is working, just by seeing, can you get that kind of flick just by lightly applying pressure on this escapement wheel. Not much, you don't need much, but just kind of lightly pressing. You can see if I let go, flicks it forward. That's the main driving force of the escapement, the flywheel going back and forth. This is a great way to test. This is actually how I tested when I was designing the escapement to see if it would work. And it should snap left and then want to snap back the other way. So you should see it snap. Also, if you give it a kick in either direction, you should see the flywheel gets extra energy added to it. You can see. So, in theory, this should work. Now, as long as you're not applying too much friction by applying this top piece here, as long as you're not squishing the components too hard. If you push down on the top piece too hard and then it presses down too much on this little barrel spacer here, or even presses down on the washer that sits on top of the flywheel, or even if the flywheel is canted slightly and it starts touching the top of it, all those can slow down the flywheel just enough to make the system not work. So I've also heard, I had someone comment saying that they actually printed the flywheel at 100% infill. I printed mine at 20%, and for me that worked. I actually tried printing at 100% and I could not get the flywheel to work. So that might be something helpful for y'all. I printed this in PLA Plus, which will definitely change the way my springs behave if you're using just plain PLA or other filaments. So I haven't tested yet with regular PLA. I don't have any on hand, but it could be possible that changing the mass of the flywheel can easily change the function of your tourbillon. So now I'm going to take the flywheel assembly from a model I know that does work. Right here, this one, you can see it works because, once again, when you're testing, very, very minimal force. You'd be shocked with how little force you need to apply for it to keep spinning. So we'll continue on with our normal build process. Apply our little pins in here. Once again, sometimes you might need a pair of pliers or some sort of tool to get these to seat properly without getting bent. My pliers in there. See that? Let's grab the last one. go. Once again, our little pin here, this should be very free spinning. Should have this. Now with your mainspring. I've seen some people suggest that maybe their spring was not strong enough. If they printed it in PLA or some other materials that might not be as rigid. So, a couple things you can try. Some people might have to try increasing the infill of the mainspring. A much easier step before doing that, before wasting any more filament, is to take your spring that you printed and then flip the direction. And then insert it into the tourbillon like this. Inserting it like this, it will still work as a spring, however, it will be much stiffer. The spring itself will be a lot stiffer. It will coil in the opposite direction. Instead of the coils getting tighter towards the center, it will actually be pushed outwards. This will result in shorter run times. However, it should mean that the tourbillon will have a lot stronger force pushing it, just in case your mainspring isn't that strong for one reason or another. But in theory, let's test this out. Obviously, don't forget your spacer. Make sure the little cutouts are facing down. Make a flat spot. There you go. Get this whole assembly. I should probably snap that in place. Okay, there you go. Whole assembly for the bottom is finished. Assembly for the top, and then take this, slide this. Your standard, line up this hole, that hole. Obviously, sometimes it doesn't work first try, other times it goes well. Okay, there we go. See, all snaps together. Theory, see, works just fine for me. I'm still trying to figure out what causes the mechanism to work for some people and not work for others. One of my main suspects is what filament being used. I have printed the tourbillons with a bunch of different filaments and different combinations of filaments, and I've found that sometimes the filament actually changes not only how the whole mechanism sounds, but also how it behaves. I found sometimes they become smoother, or they'll run. Sometimes you'll see, crank it up. Sometimes towards the very end, it would kind of there will be a little tension left in the spring. So then I would have to kind of kickstart the flywheel a couple times to get it to use up the rest of that energy. And then other times, depending on the filament used, it would leave the system with absolutely no energy left in the spring. So I'm still trying to work out why things are behaving the way they are. I'm really hoping that this guide helped y'all. Let me know if you guys have any ideas as to what could be causing issues, or what any suggestions you'll have to try to see if I can perhaps change the model slightly to improve the function of it. But till then, let me know what you guys think. Let me know if this helped y'all. If it didn't, let me know. Alright, thanks guys.